Hi all, today we are going to discuss about some more problems on development stories. So, to get a clear concept of development, you please go through the video lectures which is already posted in YouTube earlier. Okay, then after that you can watch this video lecture for better understanding. Anyway, just we can define the development. So, what is development? You just imagine any solid, that is, you just imagine a prism. Okay, so a prism is a polyhedra having two identical end faces bounded by number of side faces, right? So if we unfold all these surfaces, that is end faces as well as the side faces, and representing those faces on a plane sheet or on a plane, which is called development. So development means simply is the unfolding of all the surfaces of an object on a plane. Okay, and mainly which is used for the fabrication of sheet metal products like shipbuilding parts, fabrication of shipbuilding parts, ducts, funnel, etc. For example, you consider an oil industry. An oil industry consists of different types of storage devices. Suppose the shape of one storage tank is in the shape of a cylinder. Okay, so if you want to manufacture that vessel which is in the shape of a cylinder, if we know the concept of development, we can calculate the amount of material which is required for the construction. Thereby we can calculate the cost of that product. So that is one of the small example for development. So anyway, we are moving to problems. So the first problem is a panel prism of base edge 30 millimeter and axis 60 millimeter is resting on HP on its base with one base edge inclined 32 VP. So if the base edge is inclined 32 VP and if it is resting on its base, then you can start with one base edge inclined 32 X line, either this line or this line. Okay, complete the top view and draw the corresponding front view. Then after that, you mark the section plane, that is the section plane is perpendicular to VP and inclined 30 degree HP. So if the section plane is perpendicular to VP and inclined 30 degree HP, then that section plane can be represented as vertical trace VT in the front view. Okay, and that section plane is inclined to XY line. So here that inclination is 30 degree. So and this section plane bisect the axis of the prism. Bisecting means it's passing through the midpoint of the axis. So locate the midpoint of the axis, and to this point you draw a line, and you can draw the section plane which is inclined 30 degree to that line. Complete the section plane. Okay, and mark the section point. So if you start from left side and mark the section point in an order, then you can mark the first point on 1A, second point on 2B, third point on 3Z, fourth point on 4D, then coming back to the last edge, that is 5E, so the fifth point is on 5E. Okay, then we are going to develop the given solid. So here we have to develop only the lower portion of the prism. Okay, so no need to develop the upper portion. So this portion should be represented by using thin lines. Okay, and no need to transfer the section points into corresponding edges in the top view, because here we are going to develop the portion and we are not going to draw the sectional top view of the solid. So just develop the solid in this particular case. Okay, so just we can discuss how to draw the development of the given prism in this condition. Okay, so suppose we are developing only the lateral surface, that is the side faces. We are neglecting the end faces. Just imagine this prism with the end faces, without end faces, and we are unfolding the lateral surfaces. The lateral surface means the side faces. Side face consists of rectangular surfaces. Okay, so what will be the shape of the development which is obtained? Definitely the shape will be a rectangle, right? So the length of that rectangle which is obtained will be equal to the number of sides into the length of one side. and that length is called stretch out line. Okay, so initially you find out stretch out line, and here the stretch out length is 5 into 30 150 because we are developing a penalty. Okay, so after finding the stretch out line, you locate any point 1 on the extension of the xy line. Okay, either you can extend the xy line or you can draw another line. So it is better to extend the xy line. Okay, and locate any point on that line, and you complete this rectangle by taking length equal to 5 into 30, that is 150, and height equal to height of the prism. Okay, initially when you draw this rectangle, you can represent all lines by using thin line. Okay, then after that you locate point 2 3 4 5 etc on this line, that is on the bottom portion, such that 1 2 equal to 2 3 equal to 3 4 equal to 4 5 equal to 5 1 equal to the length of base side. Okay, then after that you draw vertical line through all these points up to the top line and locate point B, C, D, etc. Okay, then here we are opening, assuming that we are opening from the side A1. Okay, that's why we are starting with point 1A. Okay, so in this case, if you are opening from the side A1, the starting line as well as the ending line should be represented by 1A. Okay, then here we have to develop the lower portion of the prism. That's why, if you develop the lower portion, means which contain the end face also, which is at the bottom surface. Okay, so here you can take any line 1 2 2 3 3 4 or 4 5, any line as the initial line, and you complete the pentagon. It is better to represent this line at the middle. Okay, then after that you transfer all the section points into corresponding edges in the development, because we have to develop the lower portion. Lower portion means this portion. Okay, so first point is on 1A, so draw a line 2.1, that should be thin line up to line 1A, and this line also 1A, so extend that line up to this line also and locate 1. Then second point is on 2B, so locate 2. Then third point is on 3C, so transfer this point into 3C. Similarly locate 4 and 5 and join this point by dark line and represent all lines which lies in boundary by using dark line. Okay, so this way we can draw the development of the given prism. Okay, then we are moving to the next problem. So next problem is that is a hexagonal pyramid. Base at 80 mm, axis 60 mm long, resting on HP on its base with one base head perpendicular to VP. So one base head perpendicular to VP means we can start with one base head in top view, either in the left side or in the right side perpendicular to line. Okay, here it's a hexagonal pyramid, so both the line which comes in left side as well as in the right side will be perpendicular to line. So you complete the top view and draw the corresponding front, and after that draw the section plane which is perpendicular to VP and inclined 40 degree to base. Okay, so 40 degree to base means 40 degree to XY line in front view, because base resting on HP. It is resting on HP on its base. So 40 degree to HP or 40 degree to base means the front view makes 40 degree by XY line. Okay, so which also bisect the axis. So locate the midpoint and through this point draw the section plane, and you can locate all the section points. Okay, so mark the section point, and next thing is we have to develop the pyramid. So already we have discussed how to draw the development of a pyramid. Okay, anyway, we can discuss that once more in this case. So initial step is you locate point O anywhere on this space. You can choose any point on this space. Okay, the only one condition is when you locate this point O, you locate O in such a way that to occupy the whole figure in the given space. In that way you locate point O as per your convenience. Okay, then after that you draw the line OA to any angle. You can draw the line in this direction, any direction, at any angle. Okay, but the condition is the length of this line OA should be equal to the true length of the slant line. So here we have to identify which line in front view is true line. So you first you see that the top view of all these slant edges will be either perpendicular to XY line or inclined to XY line. That means no line in front view gives true length. Okay, because a line in front view gives true length only if the top view of that line is parallel to XY line. So here no line in top view is parallel to XY line. That's why no line in front view gives true length. So we have to find out the true line. So for that you can take any slant edge in top view, say OD, OC, OA, OF, any line. So here we are taking the line OD and you rotate the point D, that is rotate the line OD and make the line which is parallel to XY line. That means you locate this point D1 by rotating the point D with O as center, and you project this point D1 into XY line and join D1 dash with O dash. This line gives true line. So you measure this line and draw the line OA equal to the length of this line. Okay, then after that, with the O as center and radius equal to OA, you draw an arc to any convenient line. Initially you draw an arc to any convenient line. Okay, then you locate point B on that arc, similarly C, D, E, etc. such that arc length AB equal to BC equal to CD equal to the length of base side, that is 30 millimeter. Okay, then you join AB, BC, CD, DE, EF and FA by straight line, by dark line, and join all this point with O, that is join BO, CO, DO, EO, FO, etc. Okay, and also you draw the base by taking any line, say CD, A, B, C, or any line as the initial line or base line, and you complete the base of the solid also, because we have to develop the lower portion. Okay, and the next thing is, here we have to develop only the lower portion. That means we have to transfer all this section point into the corresponding edges in the development for obtaining the development of lower portion. So just we can discuss how to transfer all this section point. Here for the development of pyramids and cone, we are using radial line development method, which is entirely different from the previous case. That is the method which we are using for developing prisms. Okay, so here we cannot directly transfer this point 1, 2, 3, etc. into the corresponding edges in the development, because all this point 1, 2, 3, etc. lies in apparent length line, but all the slant edges represent the true length of the slant edge. So it is not possible to directly transfer this section point. What we are going to do is, initially you transfer this point into true length line. Transfer this point into true length line by drawing a line through this point parallel to XY up to this line and locate a point. So and measure this length of this point from O. You measure this line and mark that point on the corresponding edge. That is, if you are transferring the first point into the line, the true length line D1 dash O dash, you measure the length of this point from O and mark that point on OA, because the first point lies on AO. Okay, and similarly this point also will be 1. Then transfer the second point into true length line and measure the length of this point from O and mark that point on OB from O. You always take the measurement from O, because we are taking the measurement from the apex O. So here when you locate the point, you take the distance from O itself. Okay, so similarly you locate all the point and join all point lies in boundary by using dark continuous line. So this way we can draw the development of the given pyramid. Okay, I hope you understand all these problems. Thank you.